I wanted a way to run a Kubernetes cluster that I could access securely from anywhere without opening ports, setting up a VPN, or exposing anything to the public internet. To do that, I built this mini cluster running Kubernetes. It lets me expose services privately, connects clusters together, and manage everything as if it were on the same local network. This setup even ties back into my homelab cluster so I can share metrics, access workloads, and manage both environments securely as if they were on the same network. What makes it interesting is that the entire cluster runs on 3 small form factor PCs connected over 5G. It's lightweight, portable, and still powerful enough to run real Kubernetes workloads anywhere. And that brings us to how this whole thing came together. This video is sponsored by Tailscale. That conversation went something like, "Hey Tim, we heard you like Kubernetes." "Yeah? We built something for Kubernetes you might like." "Okay. We'd like to sponsor one of your videos." "Okay, what should it be about?" "I don't know, just do something cool." "Okay. And we'll also let you build a mini rack and give it away." "Okay." Or something like that. Now, we all know that sponsored videos can be a little bit awkward, so to make things a little bit better, Tailscale is giving away this exact mini Kubernetes rack I built for this project. It's powered by Tailscale, running Kubernetes, and ready for someone else to put to use. It's all running on a compact rack setup built specifically for this 3-node cluster. The whole setup runs inside of a RackMate T04U rack. It's finished in black. I've been calling it my dark mode rack. Starting from the top, there's the Unified Cloud Gateway Ultra, which handles routing, VLANs, firewall rules, and it's surprisingly capable for its size, a proper little powerhouse for managing a cluster like this. And below this are 3 B-Link Mini S machines, each running an Intel N150, 16 gigs of RAM, a 500 gig SSD, and a gigabit NIC. Now, these things make the perfect little Kubernetes node. They're quiet, low power, and surprisingly fast for what they are. I 3D printed a few custom mounts and panels to hold everything together, the PCs, the gateway, and even one of the rack panels. And if you're seeing this part, it means I actually managed to pull off the blackout acrylic panels to make it truly a dark mode mini rack. The panels attach magnetically, most of the time. The panels attach magnetically, so if you really want to go dark mode, all you have to do is pop them on and pop them off. Simple, clean, and easier than screwing panels in every time you want to tweak something. The cabling is all slim network cables to keep things neat, and the entire setup connects over 5G, because we all know how tricky it can be to work through high latency, CGNAT heavy networks. We'll see if it works, but first we need to get this gateway connected and online. After getting the mini rack together, now it was time to set up the network, power everything up, adopt the devices, and getting the unified gateway configured. So I spun up a new VLAN, added a DMZ for the cluster, and set up some zone-based firewall rules and turned on intrusion prevention to keep everything clean and isolated. With the network locked down and everything talking to each other, it was now time to move on to the software side, starting with the operating system. So I downloaded the latest LTS of Ubuntu 24.04, put that on my Ventoy drive, booted from it, and installed it. The install was straightforward overall, just your typical Ubuntu setup. Once that was done, I repeated the process for all 3 machines. Later, I realized that I should have been using my PiKVM from the start. It would have made this step so much easier. I ended up connecting it so I could update the BIOS and handle all of the configuration remotely. Then I flashed all 3 B-Link devices to make sure they were fully updated. If you've ever flashed a B-Link before, you know it's one of the scarier flashing processes. There's always that moment when you're not really sure if it's going to come back on and has this really weird screen. Anyways, after flashing, I reserved IPs for each node. You definitely want to do this for your Kubernetes nodes. You don't want them switching IPs on you later. So with the basics handled, it was now time to get Kubernetes running on all of these devices. Now, my plan was to build a new isolated Kubernetes cluster separate from my home lab. I decided to install RKE2, Rancher's hardened Kubernetes distribution built for secure environments. It meets the FIPS 142 security standard across all components and runs just like other distributions such as K3s, EKS, AKS, GKE, and I use them both in my public cluster and my home lab, and it's been rock solid. Before setting it up, I took a quick power reading just out of curiosity. The entire rack was drawing about 26 watts total. The Unified Cloud Gateway used about 10 watts, the Zigbee switch about a half a watt, and each B-Link Mini S was using roughly 5 watts. So it's pretty efficient for what's all running here. To install RK82, I needed remote access to each machine, but since they were on a separate network, that was kind of tricky. Well, because I was already running my PiKVM to install Ubuntu, I decided to install Tailscale on the PiKVM as well for remote access. After I enabled subnet routing, I could reach the entire network remotely and connect to all 3 nodes. Subnet routing is pretty cool, and it made the setup process so much easier. At first, I tried installing Tailscale directly on the nodes themselves, but I quickly found out that Tailscale packets and Kubernetes networking don't always play nice. The packets tend to collide. And that's exactly why the Tailscale operator exists. It runs Tailscale inside of a pod, inside of the cluster, keeping everything isolated. Once everything was reachable, I SSH'd into the first machine to bootstrap RKE2 with a single command. It generated a token, which then I used on the other 2 machines to join them to the cluster. A few seconds later, Kubernetes cluster online with distributed etcd and responding perfectly to my kube control commands. Now that I had the cluster running, I wanted to manage it GitOps style with Flux. Now, Flux lets me define a cluster state in YAML and automatically applies any changes I commit to Git. Now, I use Flux on my other clusters and it keeps everything consistent, reproducible, and version controlled. There are a few steps to bootstrap Flux to your cluster, but after that, you manage the entire cluster with Git commits. With Flux now managing my Kubernetes cluster, it was now time to install the Tailscale Kubernetes Operator. The operator brings Tailscale's networking directly into Kubernetes, letting you expose services between your tailnet and your cluster, access the control plane, and use it as a subnet router or even compliance session recording. It's a powerful way to link Kubernetes and Tailscale without a bunch of manual configuration. To get it ready, I went into the Tailscale admin console to create a few tags for my operator to use and set the operator as a tag owner for all Kubernetes-related tags. Then I generated an OAuth client for the operator to talk to the Tailscale API. Now, it only needs write access to devices core and auth keys. Once that was done, I had my credentials for my Kubernetes cluster. And just a reminder, these are secrets, don't share them. Now I was ready to install the operator. Tailscale supports multiple install methods, but I used Helm. Think of Helm like a package manager for Kubernetes. It bundles everything into a single configuration and applies it automatically. Since I use Flux, I wrote the Helm configuration in my YAML, committed it to my Git repository so Flux could handle the deployment. Within minutes, Flux detected the change and deployed the operator. At first, the pod failed to start, and after checking the logs in K9s, I realized I'd forgotten to include my secret. So I fixed the YAML, committed again, and a few seconds later, everything was up and running. Checking the Tailscale admin console, I could now see my cluster listed as a new machine. Success! Great success! Next, I wanted to connect directly to the Kubernetes API over Tailscale. In my Helm configuration, I enabled the API proxy feature to make the Kubernetes API accessible through my tailnet. You'll need DNS and HTTPS certificates enabled for this to work. I configured my kubeconfig using a Tailscale command, and that created a new context that I could then switch to, letting me access my cluster directly over Tailscale. Initially, the command failed, which was a good thing because it meant that Tailscale security was doing its job. After updating my grants in the admin console to impersonate Kubernetes admin privileges, I retried the command and I could see all of my nodes through the Tailscale connected kubeconfig. If you're doing this in production, it's worth setting up least privilege access with ACLs and RBAC, and ideally running the API endpoint in high availability mode with proxy groups. But for my lab setup, this approach worked perfectly. Now that I could securely access the cluster anywhere via Tailscale, it was time to deploy some apps. First up, DrawIO, the self-hosted diagramming tool. Now, it's one of my go-to apps for quickly mapping architecture visually. I created a deployment with 2 pods, and within seconds, it was up and running. This cluster is fully private, so I wanted a way to access DrawIO securely without exposing it to the public internet. While I could have used kube control port forward to my local host, that's not ideal long-term. Instead, I created a Kubernetes ingress with a Tailscale ingress class to expose it securely on my tailnet. Once deployed, it appeared in the Tailscale admin console as a new service, complete with a trusted certificate. Next, I wanted to monitor the cluster just like I do my homelab. Now, normally I'd install Grafana and Prometheus directly on here, but I didn't want to duplicate monitoring stacks. Instead, I used Tailscale to set up a secure cluster-to-cluster communication, letting my homelab cluster scrape metrics from this new one. I installed the Tailscale operator on my home cluster as well, created a new secret and auth key, and then installed Node Exporter on the mini cluster. Node Exporter collects machine-level metrics, and it's perfect for lightweight monitoring. Once that was running, I created a Tailscale load balancer in front of Node Exporter to expose that endpoint to my tailnet. On my home cluster, I created an egress service pointing to that endpoint using the Tailscale IP. A quick curl test confirmed the connection, and the two clusters were talking securely over Tailscale. From there, I updated my Prometheus configuration to scrape metrics from the remote node exporter. A few moments later, I opened up my Grafana dashboard and I saw a new node labeled Mini Cluster. All the metrics were flowing through perfectly. Kinda. Later, I made this a little bit less jank by adding multiple services and egress points to separate metrics per node. If I expand this in the future, I'll likely use Prometheus Remote Write to centralize all of my metrics at home, like normal people do. Over the last few weeks, I've gone from knowing very little about Tailscale beyond its mesh networking features to deploying operators across multiple clusters and setting up secure cluster-to-cluster communication. It really has changed the way I've thought about Kubernetes networking and how some of the hard things could be made a little bit easier with Tailscale. And about the giveaway. Tailscale is giving this away. If you want a chance to win it, you'll find all of the details in the Tailscale Discord community. It's a great place to connect with others experimenting with Kubernetes, homelab, and Tailscale setups like this one. A huge thanks to Tailscale for sponsoring this video. I'm Tim. Thanks for watching.